of more problems in context of calorimetry, which, like I mentioned to you, is an easy topic. So this next problem, as you can see here, is about 200 grams of water at 70 degrees centigrade. 200 grams of water at 70 degrees centigrade is mixed with 20 grams of ice at minus 10 degrees centigrade. Is mixed with 20 grams of ice at minus 10 degrees centigrade. Find the final result. Find the final result given the specific heat of ice is 0.5 and the latent heat of fusion of ice is 80 calories per gram. Alright. Now first of all, let us see what happens when 20 grams of water at 70 degrees centigrade gets converted into 20 grams of water at 0 degrees centigrade. Let's see what happens. 20 grams of water at 70 degrees centigrade, let's say, gets converted into 20 grams of water at 0 degrees centigrade. So then 20 grams of water at 70 degrees centigrade, as you can see here, 20 grams of water at 70 degrees centigrade to 20 grams of water at 0 degrees centigrade. How much of heat will it release? It's going to release mass into specific heat. 1, specific heat is 1 into fall of temperature 70 degree. From 70 to 0 is 70 degrees. So 1400 calories of heat will be released. 1400 calories of heat would be released if 20 grams of ice of water at 70 degrees centigrade gets converted into 20 grams of water at 0 degrees centigrade. Now, let's go to the ice side of the story. So we essentially have ice at minus 10 degrees centigrade, right? So first of all, part of this heat ice will first use to raise its temperature. Let's see if it can go all the way to 0 degrees centigrade. So first of all, from minus 10 to 0, how much of heat will 20 grams of ice require? Let's look at that. Let me see first of all whether this 1400 calories is good enough to convert ice into 0 degrees centigrade. Right? So first of all, how much of heat would be required by ice to convert into 0 degrees centigrade from minus 10 degrees centigrade? That's going to be mass of ice into specific heat of ice, which is 0.5, into 10 degrees rise of temperature. From minus 10 to 0 is a 10 degree rise of temperature. So that makes it like 100 calories. All right. So, this 1400 calories, 100 calories would be used to convert, ice at minus 10 to ice at 0. And how much of ice? 20 grams of ice, right? Now, how much of heat would be required to convert this 20 grams of ice at 0 degree to 20 grams of water at 0? Now I have 20 grams of ice at 0, which will happen, right? Now 20 grams of water at 0 degrees centigrade. So 20 grams of water at 0 degrees centigrade, the amount of heat required would be 20 into 80, which is 1600 calories. So, but 100 calories out of 1400 have been used here. Now I'm only left with 1300 calories, right? Now I'm only left with 1300 calories. Now this 1300 calories cannot convert this entire 20 grams of ice into 20 grams of water, because that's going to require 1600 calories. That means this 1300 grams will melt only part of the ice, So 1300 grams will melt m grams of ice, m into latent heat 80. So that gives me m equal to 130 by 18, which is 16.25 grams of ice. So what is the final result? We had 20 grams of ice, and only 16.25 grams of ice melted. The remaining 3.75 grams remained ice. So we have a mixture in which there is like a 20 grams of water already, right? Plus 16.25 grams of ice melted into water. So another 16.25 grams of water plus remaining 3.75 grams of ice. So we have this much of water at 0 degrees centigrade and we have this much of ice at 0 degrees centigrade. This is what happens, right? That's the final result. Let me look at another problem. So we have like a this problem number 8. We have 64,800 calories. 64,800 calories of heat is extracted from 100 grams of steam at 100 degrees centigrade. By some means, 64,800 calories of heat is expelled from 100 grams of steam at 100 degrees. So we have 100 grams of steam at 100 degrees centigrade. And 64,800 calories of heat is expelled. Now, what happens to the final result, right? So this much of heat is expelled from steam. So first of all, steam at 100 degrees centigrade would want to get converted into water at 100 degrees centigrade. That means there is going to be condensation, right? So part of the heat that is expelled will be used to condense steam to water. So then let's see how much of steam will condense. So now to 100 grams of steam at 100 degrees centigrade to 100 grams of water at 100 degrees centigrade, how much of heat would be extracted? So the heat extracted, as you can see, is mass into latent heat of vaporization, latent heat of condensation. So that's 100 grams of steam at 540 calories to get converted into 100 grams of water at 100 degrees centigrade will expel how much of heat? That means 54,000 calories of heat. That means out of the 64,800 calories of heat that were extracted from steam, 54,000 calories were used to condense steam to water at 100 degrees centigrade. I still have some heat left to be extracted. How much of heat is left to be extracted? You can see, okay, first of all, let us now see how much of heat would be required to convert 100 grams of water to 100 grams of water at 100 degrees centigrade. Let's see how much of, so now we have 100 grams of water at 100 degrees centigrade, right? And let's see what amount of heat must be expelled to convert it into 100 grams of water at 0 degrees centigrade, right? So now there is sensible heating, right? So part of the 64,800 gets utilized here for condensation. I still have like a 14,800 calories left over. Now, from 100 grams of water at 100 degrees to 100 grams of water at 0 degrees, how much of heat is required? How much of heat would be expelled? 100 grams into specific heat 1 into 100 degrees centigrade, which is the decrease in temperature. So 10,000 calories. So all right. So out of the 64,800 calories, 54,000 calories used here, 10,000 calories used up here. So that makes it how much? 64,000 calories. Now I have 800 calories to be extracted further. And what do I have? I now have 100 grams of water at 0 degrees centigrade. I now have 100 grams of water at 0 degrees centigrade. And I'm extracting how many more grams, how many more calories of heat? Another 800 calories of heat, because this is 54,000 plus 10,000, 64,000. Total extracted is 64,800. So 800 more calories to be extracted. Now, very clearly, if 100 grams of water has to be converted into 100 grams of ice, then the heat extracted would be 100 into 80, which is 8,000. 8,000. So, which means, you know, I can only extract 800 more calories. I can extract only 800 more calories. That means not all the water that you see here, not all the 100 grams of water that you see here will get converted into ice. Only part of it will get converted into ice. One that would be commensurate with extraction of another 800 calories. So 800 calories when extracted will convert m grams of water into ice. M grams of water into ice will release mass into latent heat. That means m into 80. M into 80. L is 80. So what does m turn out to be? M turns out to be 800 by 80. That makes it 10 grams of ice. So we now have 10 grams of ice at 0 degree centigrade plus the remaining 90 grams of water at 0 degree centigrade. So the final mixture would be 10 grams of ice at 0 degree centigrade and 90 grams of water at 0 degree centigrade. Thank you so much. Bye-bye.